Can everyone hear me? The back? Yeah, good. Okay, I'm not trying to sell you anything today, so mine's going to be probably a little bit more light-hearted than some of the other talks, I hope. It's slightly different from the published title, in which I'm going to be talking about adoption of Cassandra at Sky, as we have done over the last couple of years, and some of the organisational and logistical issues we've had around that, which might be relevant to some of you. And that will also give us context for the DC migration project we had to do recently. So, contents of my talk, I'll be giving you a bit about myself, a bit about Sky, a bit about Cassandra at Sky, the data center migration project without downtime, and some of our future plans. So about me, so I'm a member of the Cloud and DevOps team at Sky in the online sales and service area. Obviously, Sky's a very big organisation, so that's primarily my focus. I consider myself a DevOps DBA with a background in RDBMS, and for some reason, DBAs seem to have this reputation for saying no. Is that right? Does that reach how many bells? Does anyone? Brilliant, thank you. So there's my blog. I've got a few posts on there at the minute, not too many, but might be of interest, and views expressed are my own, to give a disclaimer to Sky. About Sky, it's a £14 billion broadcaster with over 10 million subscribers. As I said, I work in online sales and service, so that means things like rewards, help, homepage, sales, that sort of thing. We've got 13 Agile Scrum teams, so Agile is very much a big thing with us. A couple of hundred developers, so you can see that introducing a new technology, there are obviously going to be some logistical and organisational type things we need to get our heads around. We do hundreds of releases a month, mixture of auto-precision physicals and VMs, as well as some cloud apps. And what's interesting in this talk is about developer empowerment. We try and give the developers as much power as they can to get on and with least resistance to do their job and deliver for the business. And I've been told to tell you that we're hiring. So what's our initial use case of Cassandra at Sky? So back in 2011, online sales were starting to ramp up, which is awesome for us as a department. We were taking over sales from the call centres, but we were having problems with reliability and persisting in the customer shopping basket. So this is literally, you're on the Sky website in the shop pages. You select your box, your packages, movies, you might take it out, put in to the sports and that sort of thing. We're just talking about that. And we'd been using cache at that time, but we were finding under sort of load, busy periods, we'd start to experience cache misses. So that obviously leads to a very disappointing experience for the customers. They suddenly have nothing in their basket, whereas 5 minutes ago it was full of stuff, which obviously we'd like them to buy. We also had Oracle in that stack. So we thought, well, why not give it a try? Maybe we could persist our shopping basket there. So why not give it a go? Ask the DBA. Bear in mind that the payload on the shopping basket is in the region of 100K. So this cannot go into a standard row, but has to go into a lob segment. So it's quite an expensive operation. So what do you think the DBA said? Who was that? Hands up, it was me. Sorry about that. But we tried Oracle anyway. And you know what? For a while it was pretty good. It did actually do what it said on the tin. It handled the traffic, but again, as traffic continued to rise, we started to get some problems with it. And rather than trying to patch it or trying to work out more solutions for Oracle, we thought we weren't really comfortable with the solution anyway. So we decided it was time to look at alternative solutions for this. And that's where Cassandra came into our world. Sort of a very brief summary is that we did some white paper analysis, you could say, of various solutions out there for this sort of thing. And we decided that Cassandra looked like a pretty good fit. So it was the one we tried for us, partly because you get multi-data center out of the box, which is just a brilliant feature. And I don't think there's many other solutions out there that will do that for you. And disaster recovery had become quite a hot topic at Sky itself. Oops. So yeah, we set ourselves up a 4-node physical cluster. Akunu were holding our hand for part of this time to get us set up to run a performant cluster. And it was pretty impressive. We were getting 10 times the throughput from memory. than we were with Oracle without any misses or errors on the shopping basket. So after some time, this went into production and has been running our shopping basket persistence ever since. So now we've got Cassandra and Oracle MySQL, so we've got NoSQL, we've got RDBMS in the stack. Can we go further with it? You know, now their options are open. We're not just talking about RDBMS anymore, which is the default position for most uses. For, you know, developers will say, where's the database? Let me put it in there. Well, now actually you've got a choice of a couple. So before I actually move on to the adoption part, I'll just say that I took a bit of a time out and I thought, you know, think like a data scientist and, you know, consider this whole thing of ACID versus NoSQL versus CAP theorem about RDBMS versus the NoSQL thing, and scratching my head for a little while, and I thought, you know what? This is what it boils down to for me. Your RDBMS is like your New York copper, or maybe not New York, but you know, he applies the rules, he won't flex very easily, he'll tell you when to get out of line, whereas Cassandra or NoSQL seem to be, you know, all about keep on running. It will just keep going. Whatever you throw at it, it will just keep going. Data integrity, that's your problem. I don't care about that. You make sure you take care of that. Want to write a new column of data? Just start writing it down. What are you waiting for? You don't need to define your data structures. So coming from an RDBMS background, this is the kind of new world we were moving into for databases from me in those early days. At the end of the day, it's all about trust. And so you've got the one paradigm which says we entrust the development and developers completely, and we have something like a NoSQL solution. We relax all of the controls around data that come with an RDBMS. And the other paradigm is where we're capturing all that control and blocking you should you get out of line. So the question then, in this new world of ours, is why should we consider using anything other than RDBMS? What does Cassandra or NoSQL offer for us? And I would say, most importantly, are these features here more than actually what it offers from a development point of view. So what does it give us? Out of the box are the ones with stars against it. Multi-data center comes out of the box, that's brilliant. Auto-purging comes out of the box. So how many times have we all been across projects where new data is being written down, and you go and ask the question to the development team, you know, DevOps guy walks up to the development team, says, excuse me, what are you doing about data purging or archiving your data? And it's like, yeah, there's a card down there somewhere, we'll get around to it maybe next year sometime. It's like, great. Cassandra, absolutely awesome, because as you write your data down, you can set a TTL, time to live on that data. So it's brilliant. As soon as that time expires, the data's gone. It's just like magic from a DevOps point of view. We get the high throughput. In our case, that's one use case so far, which is the shopping basket persistence. And you get the auto sharding. What the auto sharding's done for us so far is less about massive volumes of data, but more about being able to use local disk of the node itself instead of SAN, which is obviously much, much more expensive. You cannot necessarily guarantee guarantee your IOPS when you're using a SAN as well. So auto sharding means that if we need more storage, we just scale out our nodes, and voila, we've suddenly got more storage and guaranteed IOPS from it, and control of the IOPS. So the teams started to get interested in Cassandra, and you know, it was all very new, and we were trying to find ways, the best way to sort of bootstrap the teams and developers, if you like. So I came up with this questionnaire, essentially out of which drops your Cassandra configuration, and it's kind of a springboard from which to think further about how you want to use Cassandra and what it can do for you. So I'll just run through this with you. Out of this, we'll be able to determine replication factor, consistency level when writing and reading, and time to live. So our two teams mentioned here is one wanted to write some journaling data, which is literally about storing journeys as customers are clicking around the site, moving around, maybe adding things to the shopping basket if they're buying. and that is literally a dump of their journey in Cassandra. The other team, as I've already talked about, is the shopping basket experience. So the first question is, can you afford to lose data? In the case of journaling, yes, you can afford to lose the data. You know what, this is only debug. We'll only be referring to it occasionally. Doesn't matter if it all disappears. Shopping basket, absolutely not, as already described. Do you need disaster recovery? Again, for the journaling, no, because journaling for a journey, tracking a journey in one data center is irrelevant for our other data center. Those will be tracked individually, so we do not need disaster recovery for that. For our shopping basket, yes, we would like to. If we fail over, we would like to not disrupt the customer journey if possible. Will you be updating the data? Journaling, again, no. Shopping basket, of course. We'll be adding and removing stuff from our basket. If updating, what are your read requirements? Must you guarantee seeing the latest data, or is eventually consistent okay? Journaling that doesn't apply, but obviously for shopping basket, we obviously want to see the latest content in the basket. Can the data be purged, which is really more like after how long can your data be purged in the ideal world? In the journaling case, it's 1 week, 24 hours in terms of shopping basket. Then the next couple of questions are not so much about how you would set about configuring yourself for Cassandra use. It's just more about understanding how it will be used, because this is a multi-tenanted system at the end of the day, so we need to make sure overall for the whole department we're managing the expected IOPS and volumes of data. So we've got what kind of volumes of data do you expect in the TPS? And out drops of that for our journaling team is replication factor of 1 in data center 1 only, and they will have a similar key space in data center 2. So this is a key space configuration. They will be, as they're reading, they'll be reading 1 and writing 1, because this data goes down once, and therefore you only need to read it once to get a consistent view of that data. And TTL is a week in seconds. For the shopping basket, we have replication factor of 3 in each of our data centers. So this will allow, when we do our reads and writes using local quorum, we'll be guaranteeing, so it's twofold really. We'll guarantee that we'll get the latest data when we read back any time in either data center if you had a disaster as well, and that you can afford a failure. So if a node fails, you've still got 2 copies of your data, 2 replicas left from which to retrieve the latest shopping basket. Again, the TTL there is described in seconds for 24 hours. And essentially, Cassandra goes through this process of compaction every once in a while. When it compacts, it will read the TTL of the data, and if it determines it's now out of the window for its lifetime, it will then just remove that completely from the database. So I'd say yes, we've crossed the chasm. Most of our teams are now using Cassandra. We have 22 key spaces in production. We've got probably still 1 specific use case, which is a shopping basket that has to be done in Cassandra. The rest of them, it's more like I have a choice now, and when it's sometimes very simple data, I will choose to write that in Cassandra. So if I'm storing a survey, if I'm storing session information, for example, or if I'm bulk loading some read-only data, it's actually very simple and elegant to do that in Cassandra, and of course you get disaster recovery out of the box. So now I'll spin forward onto the data center migration without downtime. And please note, in doing all of this, the empowerment of the users, of the developers, should I say, and the teams. You get much more control with Cassandra than you would with an RDBMS, and some of them are not relevant or configurable in RDBMS. So you have control of key spaces to be able to create, drop, update, which is the same as creating a user in Oracle or a database in MySQL. Yep, that's the same. Control of the replication factor. That's something that doesn't exist in RDBMS, but they have, the developers now have the power to control that. Control of the read and write consistency. Control of column families, create, drop updates, and control over the nodes that they will connect to in the cluster. Now, with RDBMS, obviously, you're normally connecting to 1 node, or if you're using something like Oracle RAC, you'd be connecting to a service, which would then back off to maybe several servers behind it, but there actually only still be one service presented to the application. So our pre-migration topology looks like this, which is simply 4 nodes in 2 data centers. In each data center, it's useful to note that the nodes are distributed evenly, so this will result in an even distribution of data per data center, and I'll come on to that again in a minute, to another way of viewing that. Our target topology, very similar. Now DC1's out of the way and DC3 has taken over, but they will have slightly different tokens because across the whole cluster, tokens must be unique. So how are we going to get there? First of all, I was considering doing this. There's several ways to do it, but the ones I was considering to start with do involve downtime. Essentially, because data files are immutable, you copy them from your like-for-like nodes from DC1 into DC3, and then you shut down your node in DC1, start up in DC3 as if it's a node repair. Basically, you're building a recovery node for the one that's just gone down, but that requires downtime. So this is going to be about doing it without downtime. So the first step is to obviously get your nodes into DC3, install the Cassandra binaries, then on the like-for-like basis, copy over the Cassandra YAML from data center 1, and then we adjust in there the listen address, because obviously to match the IP of the node in DC3, so that will change the listen address. And then we just take away 1 from the token as compared to DC1. So the token T1 from that first node in DC1 would be copied, the YAML will be copied to the node, like-for-like node in DC3. It would just take away 1 from the token, which seems a bit weird because it sounds like, well, the tokens aren't equally distributed, so isn't that going to lead to problems? But I'll come on to why that's not an issue in a second. I also made sure that the auto bootstrap was set to false, because when we come around to starting up the nodes in DC3, we want to do that in quite a controlled way, because obviously we're trying to do a data migration rather than just set up some new nodes. Finally, there's the network topology file that lives on all of the nodes, so all 12 nodes, and those need to be edited to take into account all the nodes and the locations of the nodes. And when I went on to one of the live nodes in Data Center 1, and I ran a node tool ring, I could see now, all of a sudden, within a couple of minutes, I could see these new nodes appearing in DC3, but they were in a down state, of course, because we haven't started anything yet. So yeah, just briefly about network topology. Essentially, by using network topology, this range that we're familiar with, which goes from 0 to 2 to 127 minus 1, which is our token range, when you're using network topology, that effectively forms these lines or these rings on a per data center basis. So the fact that I copied over the YAMLs from DC1 and put them onto DC3 and just took away 1 from it does not mean that there's some kind of clash or there's too much closeness between DC1 and DC3, because DC3 is considered its own ring in its own right. And so as long as your nodes in each of your data centers are equidistant, you're kind of good to go. You've got a good configuration. Your data will be balanced across all nodes. So I ran a check to make sure all of our key spaces were indeed using network topology strategy, which was the case. Had I found any with simple strategy in there, then I'd have had to have done some remedial work, because essentially this would have all bunched from the cluster point of view. It would basically collapse that line down into 1. And then you would see that this very uneven distribution of nodes along this line exists. And so some nodes are going to get hardly any data, whereas others are going to get a hell of a lot more. So it's critical to get any simple strategies out of your configuration. I would almost say that really that shouldn't be in, once you've moved to network topology and you've defined that in your cluster, you should not be allowed to use simple strategy, would be my point of view, rather than having the choice of both. I think when you've consciously made the choice to configure for network topology and you've got multiple data centers, it should basically stop you going back to things like this. So the next step was to start up the nodes in DC3 one at a time. Now at this point, I have to say when I went to my first node, I was expecting within a couple of minutes to be sort of pretty much bootstrapped. So to create the system key space and bring the schema up to date. But there I was like half an hour later, still seeing the log file doing stuff. It just didn't seem to settle down. I was checking the key space count and I was expecting to see that steadily increase until I had all my key spaces on this new node. But I was seeing stuff like this where it would, say be at 10 and then I'd count again and it would go up to 14. Great, more data's coming in, more key spaces. Then after a bit longer, it was dropping down to 12 again, so it kind of didn't make sense to me. And when I described cluster, I'd see that the schema for this node was not in agreement with the other live nodes, which were all matching each other in terms of the schema version. So that's when I came across this fun page on the DataStax website, which is called the Schema Management Renaissance, which describes 0.7 as the Dark Ages, greater than 0.7 to 1 as Middle Ages, and 1.1 as Renaissance. And we found ourselves in the Middle Ages, which was awesome. What this meant really is that when you set up a new node and you try to bootstrap it, it has to replay the schema as it was being used on the other nodes. So if you've done lots of changes like adding key spaces, dropping them, adding more, dropping, making changes, changing the replication factor, all of that is rolled forward on your new node. And so basically, once I knew that that was happening, whereas 1.1, you basically start up the node and it just say, grab me the latest schema and work with the latest schema. So that was a problem I found myself in there. But once I knew that, I just let it run, and it actually was so big that it took about a couple of hours before the schema agreed with all the other nodes. We were kind of bootstrapping good to go. And I knew that because when I ran describe cluster, although I've redacted the IPs here, you can see that you'll get this sort of thing where it will say schema version, some long hash, some long number, hex number, and the nodes that match that schema. And I also did run a count on the key spaces, and that matched too. So the next part was to update all the key spaces. Now, this is really our first pinch point in terms of the developer empowerment. We've said it's all for you guys. Do what you want to do. Make sure that you meet your business targets. But now we need to gain control of the key spaces to account for data center 3. So this is really a twofold process. One is to make sure for each of the teams you work out where their deployment scripts are or get involved with them to adjust their replication strategies in their key spaces to now account for data center 3. So we were going from create key space, blah, 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 strategy options, DC1 and DC2 to one where it says DC1 and DC2 and DC3. Because what we're attempting to do is have 3 data centers, all with replications, sort of independent sets of replications going at the same time. So that was the first thing, is to get control of the script. So if there's any new deployments, they would take account of the fact that DC3 is there. The next step was to actually go in through the command line client and run a sort of a manual update on the key spaces as they existed. So you can just run an update key space to take into consideration DC3. So that kind of covers you for the key spaces to make sure nothing gets missed out, nothing gets left behind. Then the next phase, which I thought this was going to be the hardest phase, to be honest with you, is where you actually try and recover the data on that node. You're basically saying to the cluster, please provide me all the data so that I can get up to date with my partition range, and you do it on the node by node, and the data center is good to go in that respect. But, we don't have masses of data. We're not talking terabytes. I think we're in the tens of gigabytes. But this is the sort of thing you'll see when you run the node tool repair minus PN, and the PN just means repair the data for that node and not for any other replicas that it's responsible for on other nodes. You see this sort of thing where it will say it will be repairing a new session. It will give you the key space and the column families it's trying to do the repair on. And you get messages like the repair for the column family is synchronized for the session, and it will go on to do more as the more exists for the column family. And eventually you'll get this last line down the bottom, which says the repair session is completed successfully. So once this was done, these are the kind of checks I ran on the cluster to make sure we were kind of good to go. I would say that to some degree it's not an exact science. It's not like doing a row count in your RDBMS and doing an exact row count on your other node that you may be doing a clone of it, for example, or if you're doing a migration project. These are the sort of checks I was doing. Was a key space count, that matched. Column family count, that matched. You can go to the data directories and run a DU just to see if your data in terms of volume roughly matches what you would have from other nodes in the cluster, because they should all roughly, using the random partitioner, all nodes should hold roughly the same amount of data. And that's not going to be exact because some nodes will be have just completed a compaction, for example. There may be snapshots in there that will also account for some of the data that will appear under DU. Then you can run nodetool ring, which will show you a list of all the nodes and show you the balance of data across the nodes, across the whole cluster. That helps, gives you confidence. If you want to go closer in inspecting, which I did on a sort of spot check basis, you can run the nodetool CF histograms, which basically takes as input the column family, the key space and the column family. And that will produce you a histogram output telling you the number of keys on that node for that key space, as well as how large each of the rows are. It will show you a distribution chart of that. So the next thing is to do the reassignment of clients. So whereas the clients before were pointing at DC1 and DC2, they now are pointing at DC2 and DC3, which requires a redeployment of the applications. So you have to go around the teams one by one, make sure they're redeploying to point to DC3, because we know we're good to go in terms of the data. Now, so that's another pinch point we have there in terms of, logistics and organizational concerns. Then we repeat the exercise of updating the key spaces, which this time will be taking out DC1, leaving just DC2 and DC3. Again, means iterating across the teams, getting hold of the scripts that they might have, the deployment scripts, as well as running a live update on the key spaces itself. Finally, we come to decommissioning. Once we're happy, and we maybe let it run for a couple of days to make sure nobody's complaining, nobody says they've got missing data, we take out the data center one by running the nodetool decommission, and then remove the nodes from the topology file. So the topology file that exists now on DC2 and DC3, we can just strip out the nodes that we have from DC1. That is essentially the way we did the live migration. Happy to say there weren't any complaints or faults or bugs or errors reported by any of the developers. So for the future, how are we going to sort of help? It's quite, the organizational challenges are actually harder than the Cassandra ones, I would say. And so how are we going to help that in the future? So we're moving, like lots of organizations, more towards cloud applications. And that's great for us in this respect, because what we can do is then abstract away the Cassandra services. So they're no longer involved with sort of hard coding, data center 1, data center 2, replication 3, and all that sort of thing. It will basically be provided to them so that they will select from their cloud, the cloud application. For example, Cassandra consistent with data disaster recovery, or it might be Cassandra single value, one data center, something of that nature. But then behind the scenes, we then got one place to make our adjustments should we have to do things like this in the future, or maybe do DC migrations or add nodes or what have you. So similar goes with the client connection pools as well. So they're no longer defining the nodes that they're going to connect to write their Cassandra data. They're going to be connecting, they're going to be basically saying they want to use a Cassandra service in the cloud, and that will handle the pool connections for them, and we can then manually adjust that in one place behind the scenes. And that's it. Any questions?
So you said you've got 22 key spaces?
Yeah.
And that is on one cluster?
Yes.
Okay.
One cluster. We started with 4 nodes, and we have 4 nodes in one data center, 4 nodes in another. Physicals are actually HP DL380s, and that's been fine for us so far. No. Because that's an interesting question. Why would it? Because the applications can connect to any of the nodes, and there's no master node. So all of them can, the work gets evenly distributed.
Do you have monitoring tools, and who looks after people shopping on your website at 3 a.m. and the problems with
Oh, we've got a whole monitoring thing going on. So we use Nagios. We don't have any specific Cassandra monitoring tools at the moment. We'll probably look to do something like that, but at the moment it's more or less just Nagios monitoring, sort of a disk, CPU, memory usage, stuff of that nature.
Just checking that the nodes are up rather than...
That they're up and the system looks healthy in sort of a general sense. Also checking the things like the heap size, stuff of that nature, not necessarily sort of Cassandra specific, but there's enough coverage there to cover most eventualities.
So have people had to restart nodes?
No. It's been remarkably resilient. So we have, one of our philosophies is to be able to sort of bare metal provision our systems, and we go through a process of rebuilding our systems once in a while. Now, to be honest with you, with Cassandra, we haven't done that in a while, but we have in the past, where we'll literally take it down, rebuild it, start it up, bring it back into the cluster, knowing that anybody with sort of important data requirements will have the replication factor correctly configured so that this won't affect them.
Sorry, I'm stealing other questions, but so the developers, we're talking about them having ownership and sort of more buy-in. One of the problems we're facing with Cassandra is they want to be able to control things like their key space, they want to be able to control the environment, but they also want the support team there in case it breaks. So how do they rest easy at night for shopping baskets?
How do they, sorry?
How do they rest easy at night? Do they do any support?
Yes, yeah. So all our teams are responsible for their own support. It's part of the whole agile way of life, I believe. They get full empowerment, they get full responsibility. We have, like 5 minutes SLAs to get to initial incidents and, some form of resolution or understanding the resolution within half an hour, even if it might take longer than that to achieve. So definitely it's not, we've tried to decentralize as much as possible. Obviously, you need a DevOps team, who's going to put Cassandra in, who's going to configure it, who's going to maybe start providing advice about it. But you need that for all the infrastructure stuff. But other than that, as much as possible, it goes out to the teams.
Do you have SSDs for your disks?
No.
No. Okay.
Standard disk.
Standard disk. And how much RAM do you have per node?
How much?
RAM.
I think it's around about 170, 172, something like that.
That's per node?
Per node, yeah.
30 gigs?
Yeah, it's about 170, I think.
Okay.
But I'm not convinced we're using all of that. And as Jonathan talked about in this morning's talk, you liberate, by going to use memory directly outside of the heap, you can then make more use of your system memory. And we're not in that position yet, but we will obviously, hopefully once we've done our upgrade, we'll get there.
Do you do any major compactions? Do you run them at
Yes.
a specific time?
Yes,
Okay.
so our major compactions are out of hours. So we're mainly a UK business, so we can afford to do this around the midnight, 1 o'clock in the morning type of time, yeah.
Which compaction strategy are you using?
Which?
Compaction strategy.
Leveled, I think it is. Off the top of my head, I don't know, but I think it's level. I think it's the whatever's the default or recommended.
What size have you been using for the level definition?
I think it's pretty much default.
The default?
Yeah.
It's a size, I think, isn't it?
Size. Yeah.
When you did the first repair and the empty new data center, the information came from the other data centers.
Yes.
And the next nodes, when you made the reveal, the information came from the other data centers.
Yes.
So, in case there's two different zones, I don't know, maybe in the US and in Europe, the data would flow 4 times across the ocean.
What I observed is that it seemed to be you run the repair, and it seemed to open up. I was looking at NetStat, and I saw lots of ports open from various nodes. It wasn't just 2 or 3 of them. It seemed to open up to lots of them. Now, I don't know if any of that's optimized to have a sense of geography or latency across the nodes. I suspect on this version that we were using that it wasn't that intelligent. Yeah.
And which kind of quorum were you using? A local quorum? Which quorum?
For what?
For queries in the database.
So it depends. So we've got 22 key spaces. Each of them will.
Had its own.
Everyone's got their own. So that was the point of the questionnaire. Out from that drops how you would like to read and how you'd like to write your data.
None of them had any issues with moving the data.
No, because we're kind of like. I didn't say it necessarily at the time, but at one point we actually were running with 3 data centers, although still connected to 2, DC1 and DC2, but we actually had 3. And so it was just a question of switching over to the third one in favor of the second one. The first one. So,
Last question.
Yeah.
You did a repair. Why not a rebuild? In that case, it's something better with repair.
What kind of rebuild do you mean?
Not to rebuild that doesn't do any Merkle tree. Just give me all the information.
I'm not sure which one's more optimal. No tool repair is the sort of prescribed method of doing this sort of thing, and it's the one we tried, and it's very performant for us. So I'm not sure I even considered doing a rebuild instead.
For indexes, the rebuild one, I'm not sure.
Hmm?
So I usually use the node to repair as well.
Yeah.
So is the rebuild one for indexes?
No, rebuild is just I have an empty node and I want all the information for this node.
Okay.
You don't have to
Yeah.
calculate if the information is correct or not. I just assume.
It may be if you have partial data on there, so you don't want to go back to the beginning. If you do a rebuild, you're basically saying go from the ground up.
Yeah.
And if it's a repair, it's like, well, I've actually already got 50% of the data, which is what would happen if you copied the data files on there and you said repair, it would actually say that I already got this much data and I'm going to collect some more. So it's probably more performant to do. But actually, if you're starting from scratch, maybe they're the same. Okay, I think we are done. Thank you. Thank you.
Any failures so far? Memory failures?
No.
Nothing?
No.
Because we're evaluating Cassandra.
Okay.
I work for Semantic now.
Okay, right.
We're evaluating Cassandra,
Right.
so I thought I might get as much out of you.
Yeah. For